PSU is a unique place. PSU is both a big university but also has a small feel. The students at PSU are more engaged than any students I've ever seen.
We are not a traditional campus where students are drawn to the typical college life. So we get students here who really want to focus on learning, and we try to provide them the best learning environment that we can.
The chemistry department at Portland State University has 4 research strengths, which are in global wellness, student success, fostering community, and future readiness. We lean into those 4 areas in our research, in our teaching, and also in our outreach. I am using my chemistry knowledge and skills to work on projects related to art conservation. With the Alaska State Museum, we're working with the Chilkat dye working group to understand the original dye stuffs that weavers used to weave in the Chilkat style. And so we're trying to identify what the original materials were, what types of plants the indigenous weavers used, so that that knowledge that has been lost can be recovered. Students working on this project are able to help the Chilkat dye working group to regain information about the past. And so it's a wonderful opportunity not only for them to put their scientific skills to use, but also to connect with people and with a culture that they knew nothing about.
We measure success as more than just grades in our courses. What that looks like for me in the classroom is really thinking about what each student is bringing into the learning environment and trying not to treat everyone the same. Some of my graduate student researchers are then investigating the impact of those practices on things like students' engagement, their motivation, and their overall sense of belonging in the classroom, so that we can understand what success looks like for different students in the learning process and be able to tailor the instruction appropriately.
We're about knowledge creation. The focus on research feeds into that. Right now, our main focus is on pancreatic cancer detection. My mom had cancer twice. My dad died of melanoma. I remember when my dad got cancer, it was like in the early 80s. And I remember feeling so helpless. At least now I feel like I'm doing a little something in return or to address that. I have a group of PhD students as well as undergrads who do research in my field. You get a chance as a student to work with practitioners in the field and have them get real-life hands-on experience here.
It's our responsibility, as scientists to solve the big problems. And one of the big problems right now is climate change. And the cause of climate change is carbon emissions. And carbon emissions are caused because the fuels that we burn are carbon-based. And so if we can find a fuel that isn't carbon-based, then we can change the future. In my lab, we research solar fuels. There's a couple of different levels that the students interact with the research in my lab. One is directly, and so we have both graduate students, undergraduate students, and high school students that go into the lab every day and make molecules and study molecules and interpret the data. But I also bring this into the classroom where students are then engaged into the, kind of becoming stewards of our world rather than just learning the basics, fundamentals of science, but understanding that there's a responsibility that comes with being a chemist. Students leaving the program at PSU in chemistry have a lot of opportunities right now. But I think whatever students end up doing, they've learned something at PSU about how to think and how to ask questions and how to challenge the world around them and the value that they have as contributors to society.